6.3 Adding, subtracting, and multiplying polynomials. Alright, let's take a look here. So, adding and subtracting polynomials. Just going through a couple little examples here for you. With adding of polynomials, basically all you can do is add like terms, which is something that you kind of already know. So x plus x, there's two x's. If we had an x squared and x squared, this whole item is your variable. So if we have 3 x's squared and we have 1 x's squared, we actually have 4 x's squared. X's cubed. If I have 5 x's cubed and I have 4 x's cubed, 5 of them minus 4 of them is just x cubed. If I have 7 x's to the fourth and I have 10 x's to the fourth and I subtract them, 7 minus 10 is negative 3 x to the fourth. If I have 8 x to the fourth minus 3x squared, this on the other hand is a trick question. This I can't do. Did you notice up here these are all the same? X and x, x squared, x to the third, x to the third, x to the fourth, x to the fourth. These aren't the same. If they are not the same, we can't do it. We cannot do the problem. We can't put them together. Okay? Just like this one. If they aren't the same, I have to leave it as is. I can't combine like terms. I can't do the problem. Alright, so it's just something to keep in mind. The next one, cubed and cubed. Since they're the same, I can add them. So 6 plus 12, 18x cubed. These aren't the same. This is x squared and x cubed, so I can't do that either because they aren't the same. So basically what this means is same exponents mean you can add or subtract them together. Multiplying, however, is different, and we kind of talked about this already in 6.1. When you multiply, all you do is basically add the exponents. So 1 and 1, so that is x squared. Remember? All I'm doing here is adding the exponents, so 3 and 4 is x to the 7th. When you multiply the numbers first, so 4 times 7 is 28, and you just add the exponents again. So x to the 6th and x to the 4th, that's x to the 10th. So do that to get a 28, and we get x to the 10th. Down here, do the 5 times negative 3 and get negative 15. And once again, we still add the exponents. So negative 9 and 5 is negative 4. And I can rewrite that because we can't have negative exponents in the denominator. So that is negative 15 over x to the 4th. Right here. So next up, we multiply again. 8 times 4 and get 32. So you multiply the numbers the same, but now it is x to the 5th and x to the negative 5th. So I add them. 5 plus negative 5 is x to the 0. And anything to the 0 power is 1. So it's really 32 times 1, which is just 32. So example 1. What I'm saying is you can add these, and you can add them by setting them up in a column if you wanted to. Just kind of line them all right up there. And when you line them up in the column, like we have here, all I need to do is just add everything that's alike. So I have 3 x's cubed and 1 x cubed, so I just add them straight down. And notice how I left a gap here because there is no x, so I just left a gap there to make it easier to add. 3 of them and 1 of them is 4 x's cubed. 2 x's squared and negative 10 x's squared, so I get negative 8 x squared. There is no other x's, so we'll come back to that. Negative 7 and 8 is positive 1, and since there was no other x's, I just bring down exactly what I had. That was a negative x, and there's your answer. But personally, I just think it's just as easy to do the problems this way. So I would just combine everything that's alike. I'll start with cubes. Is there any other cubes? X is cubed? No, which means I can't put it together with anything else. I just drop it right down. Next highest exponent is squared. Are there any other x's squared? Nope. So I just bring that right down. Next up would be an x. I have negative 2 x's and I have 12 x's. So when I add those together, that gives me 10x. And I have a 1 and a negative 4, which gives me negative 3. So once again, you only combined what is alike. With example 2, we're on subtraction, so there's only one problem, and when you do subtraction, that means you're actually subtracting the whole entire item. So when you're subtracting the entire item, alright, which is what we're doing here, when you subtract the entire item, 8x cubed and negative 2x cubed. So this is negative 2x cubed. It's a negative 6x squared. It's a positive because negative times a negative is a positive, and it is a negative 1. So basically that's what I did. I took that negative through everywhere. Now after I did that, I can just add them all straight down like I've done before. So 8x cubed and a negative 2x cubed is 6x cubed. Negative 3x squared, negative 6x squared is negative 9x squared. Negative 2x and an x is just negative x. 9 and negative 1 is a positive 8. And there's your answer. 6x cubed minus 9x squared minus x plus 8. It's the same thing if I line them up side by side. Take this negative through to everything. So it's negative 3x squared. It's negative x. Negative times a negative is a positive 4. Okay, so when we're doing this, I combine my like terms. 2x squared and negative 3x squared, so I have a negative x squared. 3x and negative x is 2x, and there is no other 4, so I just bring it down, and that's it. Once again, adding and subtracting is very simple. You just combine like terms. That's all you're doing. It doesn't matter if it's x squared, x to the 8th, whatever it is. As long as it's the same, you just add it or subtract it together. Multiplication wise speaking, that is a little bit different. So when I come back, we will start on multiplication and figure out what to do from there.